How to construct table 2 by 2 to calculate chi-square test, odds ratio, and how to do multiple logistic regression analysis. We will calculate odds of coronary heart disease in presence or absence of elevated blood pressure. We will use two variables, categorical variables. Hypertension will be considered as the risk factor for coronary heart disease. Statistics, chi-square as usual, and risk. This is not actually relative risk, but this is odds ratio. And the main condition for calculating it is to have two variables divided only into two categories. The program will not calculate the odds ratio if you have in one of these variables more than two categories. So you can do it only for 2 by 2 table. This is the limitation, and we call it unadjusted crude risk ratio without taking into account any other factors related to elevated blood pressure or heart disease. And we ask for percentages calculated from row. Okay. For tables, general information, 2 by 2 table, you see that percentage of people having coronary heart disease and having hypertension is significantly higher because chi-square test and p-value is less than 0.05 as compared to people without elevated blood pressure. Risk estimate. All you need to assess is the first row. You see that odds of having coronary heart disease in presence of hypertension is almost twice higher as compared to people without hypertension or with people with normal blood pressure. Confidence interval doesn't contain 1. It means that this group differs significantly from the group of people without hypertension. You can do the same using logistic regression. Binary logistic regression. The main condition that dependent variable usually is a disease, death, or any other health condition like hypertension, like obesity. Okay, it should be divided into two categories: disease yes or disease no. So in this case, we will use the same disease, coronary heart disease, and the same risk factor, hypertension. Advantage of logistic regression. You can use there any variables you want. You can use together continuous and categorical variables, categorical, nominal, and ordinal. And you can adjust the confounding effects of these factors in between and on the dependent variable. Options, you have to ask confidence interval. Also, you may ask Hosmer-Lemeshow test if you want to assess goodness of fit of your model. And the main condition, without doing this, you can't go on. You may describe categorical variables and to select reference group. I usually use first reference group for comparison, and I usually quote group 1 as best group, like without the risk factor. So group 1 is normal blood pressure, group 2 is hypertension. So the group 2 will be always compared to the group 1. Continue and okay. All you need to do is to look at the last table. You see we got the same odds ratio as compared like we done before with cross-tabulation function. If we have just one risk factor, it's crude odds ratio, non-adjusted, and you see the same p-value and the same confidence interval. You know there are many factors related to blood pressure, and confounding this relation with coronary heart disease. After the table, you see variables entered into your model. So you can do multiple analysis using binary logistics, same as you could do with Cox. So we will adjust this relation for each. For self-rated health, it has 3 groups. For BMI group, okay? Here we have 3 groups. And you should describe these variables as categorical, taking the first category for comparison. Before analyzing, before making any comment, you should check what is coded in what group. Okay? And you can't here put any continuous variable because the program will try to compare every year with the reference group, so we will get very large, long, and non-informative table. So do not put here anything what is non-categorized. Continue. And OK. Interpretation of the odds ratio. It's equal to interpretation of the risk ratio. So you see that hypertension increases the odds of people having coronary heart disease approximately by 35% with significant age. It is not categorized, so the program evaluates the change of the odds of coronary heart disease after getting older by 1 year. So you could say that odds of coronary heart disease increases by increasing age by 1 year. Yes, because in this variable the step is 1 year. Self-rated health, here we have 5 groups. So every single group is compared to the first group. And I see that only the last group of the worst health increases the odds of coronary heart disease by 8 times. It's huge odds. It rarely happens, very rarely happens in epidemiology of getting so high odds. And BMI group, overweight is compared to normal weight. Category 1 with category 2 is the risk factor for heart disease, but obesity as compared to normal body mass increases the odds of having coronary heart disease by 1.5 times or by 59% as compared to normal body mass. And these relations are adjusted for hypertension, age, self-rated health, and BMI, all the main factors. So in this way you can analyze cross-sectional study design. Also in this case you can analyze cohort study design, putting into the dependent variable role, death, disease, or anything you want. In that case, if you have very short observational time, follow-up time, less than 5 years. If you have long observational time, you can't use logistic. It will be more precise to do Cox regression. And please remember that interpretation of relative risk in Cox and interpretation of the odds ratio in logistic and cross-tabulation, they are equal. The one and only difference that in the Cox regression you take into account the follow-up time. for some years.